Yeah, thank you, Will. I won't dwell about us, given a lot of you know about Everoze already, but it's a bit of context and objective as to what we've been asked to do for IWEA. So in 2017, the department issued their economic analysis on design for their RES study, RES system. And in that study, they did a levelized cost of energy modeling where they were looking at large onshore wind, where we got a figure of 80 euros per megawatt hour in the 2020s. On top of that, earlier this year, there was the 70 by 30 study issued by Bryars on behalf of IWEA, where we're looking at the 60 euros per megawatt hour number, where we can look and say that we expect there to be no net cost to the consumer. And as we just saw on the presentation earlier, that could even actually possibly be a net benefit. Then we've got policy levers that could impact and have a change on those levelized cost of energy. And so IWEA has a number of objectives. We have 8 here, where they think policy levers could be pulled or made that would accelerate and help these levelized cost of energy savings on top of the general reductions we're seeing within the pricing of equipment. And so Everoze, we were asked to do some independent analysis on behalf of IWEA to look at these policy objectives and understand how those would have an impact on the original levelized cost of energy modeling done by the department. So a little bit on methodology. So to start off, we need a site. So we took a nine turbine site with what we'd now see probably as quite old technology, 2 megawatt turbines, a 20-year operational life, 36% capacity factor, 7.7 meter wind speed, so reasonably low for Ireland. CapEx and OpEx were based on the department's model, but we also bolstered that with our internal knowledge from the projects that we support through Everoze, and then a weighted average cost of capital of 6.6%, which, again, looking at a Grant Thornton study recently, that looked reasonably appropriate. So the model we used was a pretty standard discounted cash flow model, and then we looked at all of the policies and the impact of those policies on these projects. So that will impact either the energy production, your CapEx, or the OpEx on the project. And then that gives us a relative impact on the levelized cost of energy, looking at the base case. Now, in bold at the bottom, possibly not bold enough, is probably that we're not trying to predict bid prices or strike prices for the new auction. I do not want Simon to be said that he stated these are the prices. And if you were thinking of price, think of a number that you think is suitable and probably divide by 2, and you might be close. So what are the scenarios we've looked at? So we split them into 3 areas. There's planning, grid, and tax reforms. And so we'll go into each of those and look at where we can see some benefits. But on top of that, we've also looked at where the negative sides are. So we've got the development guidelines coming through. Are there things in there which can be negative? We also had the planning talk earlier with where we're talking about the impact of noise on the guidelines, and then also the impact on tax on projects as well. So we're going to have a look at that in terms of what tax impacts we have that are coming through. So let's start off with the planning and turbines. So let's just go back to the base case assumptions. So a 90-meter rotor on an 80-meter hub. So probably the majority of the projects that we saw being built 3 years ago, and still today, we'll still start seeing some 90-meter rotor turbines coming in. That gives a 125-meter tip height, and we've got to look at wind shear, number of turbines, and spacing allowances. And then we applied the best practices in terms of losses to get an energy production for those. So what happens if we increase that? So now we go to the 117-meter rotor diameters on a 150-meter tip. So as we saw earlier in the planning talk, we're actually seeing projects with planning being built already with these size turbines. And that represents a 12% reduction in your levelized cost of energy just by stepping up that size. And that's through getting higher wind conditions, so turbines higher up, so the shear is improving your energy resource. We're reducing the level of capex on the project per megawatt, and then the OpEx per megawatt is also reduced. So if we take that a step further and go to a 180-meter tip with a 150-meter rotor diameter, you'll see around the room, we're certainly in the conference looking at the manufacturer stands, there's plenty of manufacturers offering these 150-meter rotors on 4 or 5 megawatt turbines. So again, we're seeing a much better wind resource and reduced capex and OpEx per megawatt. And so when we get to that 180-meter tip height, we can see a 27% reduction. And if we go further to a 200-meter, obviously there's still going to be better savings there. But I guess the ask here isn't to say we need policy to enable us to do this, because the policy isn't currently restricting to say you can't install a 180-meter turbine or you can't install a 200-meter turbine. But the guidelines need to support, or at least be clear in terms of to enable developers to bring these projects in where it's suitable. Is there a suitable landscape that these turbines can work? We can reduce the number of turbines and improve the energy, and also have net benefit through reducing the overall levelized cost of energy and the impact of the end consumer. So this is going to be our biggest saving if we can get these in. So other scenarios, now we've got to get a bit negative, noise. So as we heard earlier, if we go to the WHO guidelines and start to change various aspects and start including tonality effects, we can start to see a negative impact on our levelized cost of energy. So we've not done the specific analysis ourselves, but IWEA went out to the members and asked them to model their existing turbines and projects based on the new guidelines. And there was quite a wide range given, which was some of them were even higher, up to 20%, and some less, but the average was around 10%. But those noise impacts could have quite a significant impact on projects where, as mentioned earlier, that is there an inherent noise issue in Ireland? Yes, there are a few projects which have had issues, but is the sledgehammer cracking the nut analogy appropriate here? Life extension. I guess most investors in the room will probably automatically be assuming 25 years on the projects. Here we look at the impact of going to 25 and 30 years. So should we be automatically looking at 30-year planning permission for projects? And again, we can see the benefit. Now, again, being a technical advisor, I don't want to be stood up here saying all of your turbines are fine for 30 years. We've got certification for 20 years with the manufacturers. We are starting to see manufacturers looking at developing certification for longer periods of time. But you can do analysis on your projects looking at site-specific loading, and where you do have more benign conditions, less turbulence, etc., wind shear okay, you should be able to expect some form of extension, life-extended operation of your projects. And the original sort of 2 megawatt class of turbine that we saw going in, those are getting to later life operations now, and we're starting to get some real-life examples of extended life. Next, simplified planning. Again, this was mentioned earlier about the uncertainty in the planning process, the time it takes, the appeals process, et cetera, et cetera. So again, if this is streamlined and we have developers have the opportunity to reduce the amount of time and cost in that DevEx, again, we can start to see some marginal savings. So moving away from planning and onto grid development reform. So unfortunately, a couple of negatives to start off with again, which I think as investors in your room, you've really got to consider as your downside scenarios. So constraint. The base case model was just looking at 1% flat constraint. But if we're going to meet our 2030 targets, there's going to be a significant amount of generation going onto the system, which requires a significant amount of reinforcement through air grid and ESB. And if that lags behind, as we've seen in the Southwest, for example, on some of our refit projects where we had significant curtailments throughout some years on those projects, we can see a significant impact on those projects. So, and this is a risk that investors are going to have to take on board unless they can somehow get some protection, whether that can, or surety that the grid infrastructure will grow with the projects and not lag behind. On a very similar vein, curtailment. The base case, we modeled the curtailment levels in the 70 by 30 study. And again, speaking to Rory last night, I felt our 5% starting base case was probably about it's very similar to what we're actually seeing this year at the moment. But a downside scenario, again, similar to constraint. If the DS3 program and the other flexibility programs that are going to follow that, if those lag behind the installation rates of turbines, again, we're going to start to see significant spikes in curtailment, especially if we think that in the latter years we might start to get offshore projects coming online, installing 400-500 megawatts at a time, maybe a gigawatt in a year. What impact is that going to have in curtailment if we're not up to speed with the programs to support that up front and also the interconnectors? So these are stress tests that people need to take into account. Other grid scenarios, system charging reform. I was looking at this the other day and looking at projects at TUOS costs and looking at the model for a lender and realized, the latest TUOS has come out for this project, and I compared it to the previous projects and noticed a 7% year-on increase in the projects, and realized that every year for that project I've seen quite a significant increase. And so, again, there's a large price that developers are paying here through premiums and financing, et cetera, because there's a lot of uncertainty over these prices. Changes in TLAF and use of system charges create a level of uncertainty. And so through the analysis here, looking at putting some more certainty over that and ideally trying to reduce those costs, again, we have a net benefit on the weighted average cost of capital, which then reduces our levelized cost. Again, smart connections. I'm sure Rory and the others in the network session will give a bit more information on this. But again, thinking about, can we be smart with the technologies that we're using, use stranded assets, share grid infrastructure as well to reduce costs. And again, a modest saving and levelized cost of energy. And again, balancing costs. I mean, the initial projects that we saw coming through with ICM coming forward, we're seeing 4 megawatt hours. And I'm aware there are other projects which are potentially paying a lot less through the systems that are set up. But again, if we can move to a system where we're paying more like 1.5 megawatts, 1.5 euros per megawatt hour, then there's some real savings to be made there. Okay, so that's done on grid. And then tax and policy reforms. What is there? So there's a few things that probably be benefits and also hitting us. So business rates, we heard before. So we had a figure earlier of 20,000 to 25,000 are the numbers that people should be putting in their financial models or stress tests in relation to business rates. And compared to projects that were originally assuming 7,000 per megawatt, that represents a 5% reduction in your levelized cost of energy. Grid capital allowances. Again, looking at some marginal gains here where we start to see the cost of your grid being treated as capital and getting the tax benefits from that. So again, a marginal benefit through changing the way that capital is treated. And again, land tax reform. So I guess this is looking at solar projects and the tax associated with the lease costs for those projects, meaning that solar developers are effectively able to offer lower percentages of revenues for the leases compared to wind projects because the landowners are taxed a lot less. And if there was a level playing field and we would onshore wind was treated the same, again, we start to see a benefit. So to conclude, if we were a glass half full type of person and we saw all of the benefits come in that we've modeled in there, compared to the department's original model of 80 euros per project per megawatt hour, and we applied all of these, that'd be a 53% reduction in the levelized cost of energy. And that would take us well below the 60 euro per megawatt hour figure that we had in the Bryars report. But if we get glass half empty and all the negatives come in, but we don't start to see the benefits, the negative aspects, if we've got noise, we start to have serious issues with constraints and curtailment because we're lagging behind there and the business rates reforms stay as they are. we're seeing as a 35% reduction. So when you combine them both, we're still seeing some reduction. But if we want to think about for the end customer, the Joe Bloggs in Ireland, if we can bring in these policy reforms, you're going to see some good net savings to the average person in Ireland. So the objective, 25% reduction is what we would need based on that model. And so that's, and what would enable that? More turbines with larger tip height, with larger tip heights, larger rotors. That's the biggest one thing that we can do to reduce the cost of energy. And then lifetime, call out to your manufacturers, suppliers. We want you to certify the turbines for a longer lifetime. Do the analysis up front to tell us that we can operate those turbines for longer. Get the planning in for a longer operational lifetime. Let's do some grid charging reform and see if we can reduce those costs and make planning and tax more efficient. Then the barriers, again, noise is potentially a big concern. It's probably the biggest concern. And then I think equally, constraint and curtailment. If they've not got right, then people bidding in could have a serious hit later on their projects. Okay, that's enough from me, so thank you very much.